Okay, so we're diving into something pretty extraordinary today. It's a document that makes a huge claim and then tries to back it up with math. We're talking about using a rigorous mathematical framework to prove a religious prophecy. Yeah, you heard that right. Let's get into it.
So let's just get right to it. The big question here is, can you actually prove a prophecy with math? I mean, can you use statistics to test a religious claim? In this case, the claim is that a man named Zarif Muhammad is the prophesied Mahdi. It's a really bold idea, right? So we're going to break down exactly how this paper tries to pull it off. Okay, so the main tool they're using for this whole thing is something called Bayesian analysis. And really all it is, it's a mathematical way of learning from new information. You know, a way to update what you believe when new evidence shows up. The best way to think about it is like a set of scales. You start with a certain belief. That's your starting point. Then, every new piece of evidence you get, you place it on one side of the scale or the other, and it starts to tip the balance. It's all about adjusting the probability as you learn more.
So, where does the model even begin? Well, it starts by building a foundation, looking at the basics. It examines how Zarif Muhammad's own personal profile stacks up against traditional descriptions of this prophesied figure.
First up, they look at his name and his family line. The paper says these are a direct match for what the prophecies describe. But then it gets a little more symbolic. It points to his birth year, 1992. Now, according to the analysis, that year is significant because it contains the number 19, which is a key code we'll hear more about, and 92, which, get this, is the numerical value of the name Mohammed in the Abjad system. That's an old system where letters also represent numbers.
So, you might be wondering, how much does that actually matter in the grand scheme of things? Well, the model assigns this evidence a score, a Bayes factor of about 95. What does that mean? It's basically a multiplier for your belief. It's saying this evidence makes the claim 95 times more likely to be true. So, if the claim is true, seeing this combo of name, lineage, and birth year is 95 times more probable than if it were false.
Next, the analysis looks at his physical appearance. It pulls from the Hadith, which, are the traditional sayings and traditions of the Prophet Muhammad that describe specific features, things like a broad forehead and a prominent nose. And, according to the source we're looking at, witnesses have confirmed that Zarif Muhammad has these exact traits.
Okay, so what about this piece of evidence? This cluster of physical traits gets a Bayes factor of around 36. So not as heavy as the name and lineage, but the model still says it makes the claim 36 times more likely. Another piece on the scale. And the last piece in this first section has to do with timing. The paper notes that he appeared during a time of global strife and turmoil, which lines up with what's expected in the prophecies. Now, the analysis itself admits this is kind of vague, right? I mean, lots of times in history could be described as full of strife. So, because it's less specific, this one gets a smaller boost, a Bayes factor of just about 10. The thinking here is that it's still 10 times more likely for the real deal to show up in a time like this compared to some random person making the claim.
Okay, so we've covered the basics of his profile. Now the analysis shifts gears. We're moving beyond physical traits and timing and into the world of ideas, what the paper calls his intellectual fingerprint.
And this is all about a theological framework he introduced called Absolute Divine Infinity Theory, or ADI theory. The document presents this as a totally groundbreaking new system that connects theology with, believe it or not, math and philosophy. So the argument isn't just that it's a clever idea. The analysis frames it as the kind of profound, game-changing wisdom you'd only expect from someone who's divinely guided.
And this is where the numbers start to get really big. We see a huge leap in the weight of the evidence here. The model gives this theory a Bayes factor of, get this, 95,000. The reasoning is that the odds of an ordinary person coming up with something this profound are just astronomically low. So, if you accept that premise, it becomes incredibly strong evidence.
But hold on, because according to this analysis, there's one piece of evidence that is so powerful it makes everything else we've just talked about look tiny. This is what the paper presents as the absolute core of its entire mathematical argument.
What is it? It's all about these incredibly complex layered numerical patterns found hidden inside the text of the Quran. We're talking about codes 19, 7, and 11. According to the paper, Zarif Muhammad is the one who uncovered these structures, which are described as being separate but also woven together.
The paper doesn't mince words here. It literally calls this a smoking gun. It says they ran millions of computer simulations, and the probability of these incredibly intricate patterns just happening by pure chance is, for all practical purposes, 0. Not unlikely, 0.
So what's the base factor on a smoking gun like that? Brace yourself. It's 10 to the power of 30. That is a number so big, it's honestly hard for our brains to even process.
Let's try to put that into perspective. That's a 1 with 30 zeros after it. It has a name, a nonillion. So what the model is saying is that this single piece of evidence makes the claim a nonillion times more likely to be true. It's just a mind-bogglingly huge number.
Okay, so we have all these different pieces of evidence, right? Some small, some, well, non-Julian sized. So how does the model put it all together? Let's take a look at the final math.
All right, so here's a quick rundown of the 6 main clusters of evidence we've talked about. You can see the Bayes factors listed out. You've got name and lineage at 95, physical traits at 36, but then you see that Quranic miracle at 10 to the 30th. It's pretty clear that while the other pieces add a little weight to the scale, that one piece, it's basically the whole ball game. It carries almost all of the mathematical power here.
So here's how they do the final calculation. Step 1. They start out being super skeptical. The model assumes, before looking at any evidence, that there's only a 1 in a million chance that this claim is actually true. Step 2. They take that starting number and multiply it by all those Bayes factors we just saw. And then, step 3. They see what the final updated probability is.
And this chart really shows you what's going on. You start way down with those 1 in a million odds against the claim. But then you introduce the combined evidence, which all multiplied together comes out to something like 10 to the 39th, and it just completely flips the script. That initial skepticism is just washed away. And the final odds? The model lands on 10 to the 33rd 2-1 in favor of the claim.
So what does that even look like as a percentage? The paper puts the final probability at over 99 and then 3 nines after that. It's a number so close to 100% that the difference is basically meaningless. The model is essentially screaming, this is a certainty.
And to quote the paper directly, this level of confidence surpasses forensic DNA match standards and enters epistemic finality territory. In other words, they're saying the statistical case is as rock solid as you can possibly get, even more certain than a DNA match that puts someone at a crime scene.
And that brings us to the end of our walkthrough of this analysis. The math as presented leads to a conclusion that is, well, about as certain as a model can be. Which leaves us with a really big final question, doesn't it? When a mathematical model spits out a number that's effectively absolute certainty, what are the next questions we should be asking?